and machine learning was so different at that time. There was very little data. Algorithms, at least in computer vision, did not work. There was no industry. As far as the public was concerned, the word AI doesn't exist. But there is still a group of us. I think we just had an AI dream. We really, really want to make machines to think and to work. And with that dream, my own personal dream was to make machines see. Because seeing is such a cornerstone of intelligence. Visual intelligence is not just perceiving, it's really understanding the world and do things in the world. So I was obsessed with the problem of making machines see. One problem always haunted me, and it was the problem of generalization. If you work in machine learning, you have to respect that generalization is the core mathematical foundation or goal of machine learning. And in order to generalize these algorithms, these data, yet no one had data at that time in computer vision, we have to bet that there needs to be a paradigm shift in machine learning, and that paradigm shift has to be led by data-driven methods. So, of course, you all know the past. It's really hard to summarize the past 5 or 6 years. For me, we're living in such a civilizational moment of this technology's progress, right? While computer vision, as a computer vision scientist, we're seeing this incredible growth, from ImageNet to image captioning to image generation using some of the diffusion techniques. While this is happening in a very exciting way, we also have another extremely exciting thread, which is language. So and of course, the elephant in the room is there's a lot of data on the internet for language. And where is the data for spatial intelligence? It's all in our head, of course, but it's not as easily as accessible as language. So these are the reason it's so hard, but frankly, it excites me because if it's easy, somebody else has solved it. And my entire career is going after problems that are just so hard, bordering delusional. And I think this is the delusional problem. Thank you for supporting that. There is the LLM. A lot of what we see in LLM is really writing scaling law all the way to happy ending. And you can just brute force self-supervision all the way. Constructive world model might be a little more nuanced. The world is more structured. There might be signals that we need to use to guide it. You can call it in the shape of prior. You can call it supervision in your data, whatever it is. I think that these are some of the open questions that we have to solve. But you're right. And also, if you think about human, first of all, we don't have all the answers even to human perception, right? How does 3D work in human vision is not a solved problem. We know mechanically the two eyes had to triangulate information. But even after that, where is the mathematical model? And we're not that great. Humans are not that great as 3D animals. So there's a lot that is to be answered. So we are definitely at World Lab. I'm just really counting on one thing. I'm counting on we have the smartest people in the pixel world to solve this. I'm not going to be able to talk too much about the details of World Labs per se, but in terms of spatial intelligence, that's what also excites me. Just like language, the use case is so huge, from creation, which you can think about designers, architects, industrial designers, as well as just artists, 3D artists, game developers, from creation all the way to robotics, robotic learning. The utility of spatial intelligence model or world models is really, really big. So, and then there are many related industries, from marketing to entertainment to even metaverse. I'm actually really, really excited by metaverse. I know so many people are kind of still like, it's still not working. I know it's still not working. That's why I'm excited, because I think the convergence of hardware and software will be coming. So that's also another great use case down the road. Around 2018, AI was not only taking over the industry, AI became a human problem. Humanity will always advance our technology, but we cannot lose our humanity. And I really care about creating a beacon of light in the progress of AI, and try to imagine how AI can be human-centered, how we can create AI to help humanity. So I went back to Stanford and created Human-Centered AI Institute and ran that as a startup for 5 years. I was very proud of that. So in a way, I think I just love being an entrepreneur. I love the feeling of ground zero, like standing on ground zero. Forget about what you have done in the past. Forget about what others think of you. Just hunker down and build. That is my comfort zone, and I just love that. First of all, interdisciplinary AI to me is a really, really exciting area in academia, especially for scientific discovery. There's just so many disciplines that can cross AI. I think that's a big area that one could go to. On the theoretical side, I find it fascinating that the AI capability has 100% outrun theory. We don't know how, we don't have explainability. We don't know how to figure out the causality. There's just so much in the models we don't understand that one could push forward. And, the list could go on. In computer vision, there's still representational problems we haven't solved. And also, small data, that's another really interesting domain. And so, yeah, these are the possibilities.